So, hello everyone, my name is Cosmin Delea. I'm from Fraunhofer CML Hamburg, and I'm here to present the SeaClear project. SeaClear stands for Search, Identification, and Collection of Marine Litter Using Autonomous Robots. Okay, our partners are TU who is coordinating this whole project. Fraunhofer CML is doing the technical coordination and also the system integration. Then we have Subsea Tech from France, who is in charge of the hardware and enhancing their waterborne robotics for our project, together with TU Munich, which is in charge for the collection system of the litter. Then we have University of Dubrovnik, Croatia, who's in charge of the control of the aerial robotics, together with the University of Cluj-Napoca, Romania, which is in charge for 3D mapping of the litter and also for the exploitation plan. And last but not least, we have our end users, Dunea from Dubrovnik and Hamburg Port Authority, who design our case studies. Okay, our ambition is actually to create the first solution for collecting marine litter using autonomous robots. We aim to do that at 3 levels or stages. First, we would like to gather the data required for mapping this litter and do the identification of the debris so that we recognize what is waste, what is sea life. Then we would like to do the collection, the proper collection, and of course the remapping, because in the water column we expect that the waste will not stand still, of course. And last but not least, we would like to have the high-level control from shore, in which we have the command of an authorized operator, and in our vision, we would like to have an end user who can monitor the whole application or the whole pipeline using a web application, web app. Okay, our approach is depicted in this picture. We will use waterborne aerial robotics. Starting now from up to bottom, we'll have an offshore deployed USV, who will be our powerhouse, the robot that will handle the computational workload, which will be permanently connected to the shore, and also to the aerial and underwater robotics. In the lower level, I don't know if I can, we will have a collection UUV and an UAV, an aerial robotic, that will gather the data needed for designing or creating the 3D litter map. And later we have the collection UV, who will be obviously in charge, together with the USV, for collecting the actual litter. And we will add in the loop another observation UUV for remapping, as we talked before. So, first of all, I would like to say for the impact side that we are a heterogeneous group who are coming from very different backgrounds and trying to match or to combine academic research, applied science, and do a business plan. In that sense, we expect to strengthen the excellence of European robotics with various algorithms for detection, using deep learning, advanced control techniques for collaborative control, and also grasping robotics. Then we would like to apply this knowledge into this overall system, who should solve an immediate problem and hence boost the possibility, have the possibility of using robotics in a new and promising area, such as ports cleaning and tourism revival scenarios. Then we would like to measure our performance, and if we reach our objectives, then we can consider that this project will be opening a new market for robotics, and hence this outcome can be further developed through a spin-off or startup through a business plan. And last but not least, we would like to lower the deployment barriers for such a system and we would like to prove that the system is scalable with reasonable complexity and infrastructure, and hence basically revolutionize the world by solving intelligently one of its biggest current problems, namely marine waste. Yeah, that's SeaClear. Thank you very much, and I am willing to answer more questions at the poster, and looking forward for talking with you.